Well control is a complicated aspect of science that requires a great matter of accuracy and commitment to standards. The main objective of well control is to keep the formation fluids contained inside the respective formations. This means the prevention of kicks and eventually blowouts. To prevent such occurrence, the drilling fluid weight must be calculated correctly to be slightly higher than the formation pressure exposed during drilling. However, in some instances, abnormal pressure zones are encountered. These pressures will contradict the normal pressure calculations made during preparation of drilling fluid weight. Prediction of abnormal pressure zones is a cornerstone in the science of well control to prevent underbalanced conditions. There are many reasons that cause abnormal pressure. We will discuss them one by one. Number 1. Undercompacted shale. During normal compaction, the volume of the sediment is reduced as the grains are squeezed together due to the weight of the overlying sediments, which causes the expulsion of the intergranular fluid and a reduction in porosity. So, there is a balance between the overlying overburden pressure and the expulsion of fluid. However, this balance is disrupted in the case of undercompacted shale, where the rate of sedimentation and compaction of sediments is higher than the rate of fluid expulsion out of the formation. This causes the formation fluid to be eventually trapped inside the formation without any further expulsion, causing the porosity to stay the same as well. Any extra pressure caused by an increase of overburden pressure due to more sedimentation will be carried and stored by the formation fluid, causing an abnormal formation pressure. This balance may get disrupted in two ways. The first way is an increase in the rate of sedimentation, which is controlled by geological factors. The second way is a decrease in the rate of expulsion of fluids due to low permeability or deposition of a permeability barrier. Undercompacted shale is considered as the most common reason for abnormal pressure. It mainly targets shale zones due to their lower permeability, which hinders fluid expulsion during sedimentation. Number 2. Deposition of evaporites. It causes abnormal pressure in two ways. The first way is by preventing the expulsion of formation fluids during sedimentation. This is a similar case to undercompacted shale, while the second way is due to the ability of evaporites to transmit the overburden stress from above in all the three main directions. This may even cause the generation of a pressure up to more than double the normal pressure inside the formation. One of the special cases of evaporites deposition is salt diaporism. Diaporism is the penetration of a formation by a plastic, mobile, and less dense underlying formation, which is typically salt. This plastic behavior is activated at elevated temperatures and pressures, which causes the salt formation to move upward due to its lower density, forming salt domes in the overlying formations. Abnormal pressure will be generated in this case due to many reasons. In addition to the previously mentioned reasons due to the deposition of evaporites, abnormal pressure is also generated due to the creation of tectonic stresses in the overlying rocks. These stresses may cause the formation of folds and faults. Folds or anticlines are structures which are susceptible to abnormal pressure if they are overlain by an impermeable formation or a trap rock. In addition, gases tend to accumulate in the crest of the anticline. When the pressure due to gas gradient is subtracted from the formation pressure, the pressure at the crest will be significantly higher than the pressure at another point at the same level. That's because the gas gradient is significantly lower than the formation fluid gradient. Faults are susceptible to abnormal pressure as well if they are overlain or lifted against an impermeable formation. Moreover, if uplifting is not accompanied with fluid expulsion, the fluids will maintain their same pressure but at shallower depth, causing higher pressure gradient. Number 3. Piezometric level. It is an imaginary surface which defines the level to which groundwater will rise in a well. Simply, this can be expressed by the water table level. If this level is higher than the well side elevation, abnormal pressure will be generated. That's because the head represented by the difference between the piezometric level and the well side elevation has been ignored and not taken into account. Number 4. Thermodynamic processes. High temperatures may cause the thermal cracking of longer hydrocarbon chains into shorter ones. This thermal cracking can result in 2 to 3-fold increases in the volume of hydrocarbon. If this occurs in a sealed environment, high pore pressure could result. Number 5. Osmosis. It is the process of spontaneous flow of fluid from a more dilute solution to a more concentrated solution across a semi-permeable membrane such as clay layers. If the flow is towards an isolated formation, then a pressure buildup can occur. The osmotic pressure across the membrane is proportional to the concentration differential. There are other reasons for abnormal pressure such as permafrost and diagenesis. However, they are not considered as the main reasons encountered in most oil and gas fields, so they are beyond the scope of this video. There is no way we can avoid the occurrence of an abnormal pressure because it depends on geological factors. However, we can detect and plan ahead correctly for encountering an abnormal pressure formation. The most common 3 methods used for abnormal pressure detection are mud logging, MWD and LWD, and direct methods. Number 1. Mud logging methods. These methods rely on kick warning signs. Since they were discussed in the previous video, they will be overridden. Number 2. MWD and LWD. These are short for measurement while drilling and logging while drilling respectively. Measurement while drilling is used to measure drilling parameters by the utilization of tools that translate drilling fluid pulsations into readable measurements such as downhole weight on bit and torque. While LWD uses special instruments that contain built-in receivers that measure specific parameters such as porosity and saturation. Number 3. Direct measurements. This is considered as the most accurate method for pressure identification. There are 2 tests that can be used to get direct measurements from formation. First test is RFT or Repeated Formation Tester. The RFT is a wireline tool designed to measure formation pressures and to obtain fluid samples from permeable formations. When run into the hole, the tool can be reset any number of times. The RFT is only useful after the whole section is drilled and can only work across porous and permeable zones. The pressure, flow rate, and time data can be used to calculate reservoir characteristics such as permeability. Second test is DST or drill stem test, where a drill stem with a packer is run and set just above the zone to be tested. The packer is set and a DST valve is open to allow the reservoir to communicate with the inside of the drill stem. The drill stem is run with several pressure gauges. The purpose of the pressure gauges is to record the downhole pressure. The pressures recorded during the test are used to calculate reservoir characteristics such as formation pressure and permeability. In this video, we have discussed different sources of abnormal pressure and how to detect it. If you liked this video, make sure to press the like button. Also share it with your friends for their benefit. If you want to know more about well control procedures and equipment, make sure to subscribe to our channel. Moreover, drop a comment in the section down below if you want to know more about a specific topic in the oil and gas field. Thanks for watching.